All right, off we go. All right, so we're investigating what multiplication is listed here. And so I'm going to bring up the different groups. I got 3. We're waiting for one more in here. Okay, so one group saw in here 23. Let's get my highlighter out. Times 12. So 10. Another 10 is 23. Sure, I see that. And then 10 down and 2 more is 12. And that equals 1, 200, and then 10, 20, 30, 40, 50, 60, 70, and then 6, 276. Yeah, I think that looks pretty straightforward there. Nice job. Okay, let's see how another group showed it. Next group. Okay, so we have our hundreds, our tens, and our ones, and they saw their 2 hundreds, 7 tens, and 6 ones for a total of 276. Okay, excellent, good job. Next group, and I think I'm still missing one group's page, if you could get me that. Here they see, let's blow that up a little bit. There we go. The area equation is length times height would be 23 times 12, gives us a total area of 276. Beautiful, I love it. Okay, and then the last group here has 23 by 12, area model is 276. Yeah, so the base 10 blocks give us a great way to show how a more complicated area looks like. Now I'm gonna just take this a step farther by combining 2 of the groups of work. So, and there's no particular reason I'm grabbing any particular group except you all highlighted different parts. So there were several groups that just had the 12 times 23 or the 23 times 12 is 276. And there was one group that also broke down the parts, the hundreds, the tens, and the ones. So I'm gonna put all that together. So let's grab, not that one, let's grab a blank one here, okay. And I'm going to try the pen, see if I can get it to work today. And I prefer not to write in red. Let's write in blue. So again, what I was hoping you would see is definitely that there was 20. Is it not going to work today? Oh no, it worked yesterday. Really? Why does it work some days and not others for me? All right, let's screenshot it into my other notebook. Screenshot that. New page. Okay. So again, my hope was that you looked at this and you saw in one direction there was 1023. By the other direction, 12. And altogether, that gives us some 100. So I see over here 200, and then I see some 10. So over here, I see a 30 there, and then I see a 40 over there, and then over here, I see a 6. So now I just want to consider, you know, how this relates to multiplication algorithms. And I'm going to introduce a new algorithm here. New algorithm. Isn't that a great word? Algorithm. New process. It's called the expanded algorithm for multiplication. And remember, we saw an expanded addition. The expanded algorithm. And then we'll relate that to our standard algorithm. So here I am multiplying 23 by 12, and I'm going to write it in the stacked way. And 2 times 3 is definitely a 6, and there's my 6 over there. Okay. Then we usually move on to the 2 times 2 next, but that's really not 2 times 2. It's 2 times 20, and 2 groups of 20 is 40. So underneath here, I'm going to write 40. So I'm done multiplying by the 2 in the bottom. Then I move on to the 1 over here from the 12, which is really a 10. 10 times 3 is 30, so I'm emphasizing place value. And then 10 times 20, 10 groups of 20 would give me 200. Okay, so the expanded algorithm emphasizes the place value of each number. And in the picture here, right, my 6 is represented my 40 is represented, my 30 is represented, and my 200 is represented. So the expanded algorithm basically outlines this picture here. And then we put it all together. There are 6 ones, there are 4 and 3 or 7 tens, and there's just 2 100s for a total of 276. So that's called the expanded algorithm. We have our standard algorithm, which most of us grew up with. So standard, oops, I can't spell as usual, standard algorithm is 23 times 12. And, you know, we stick with the 3 times 2 is 6, that's the same. But then when we do 2 times 2, we say 2 times 2 is 4, and we write that 4 over here. So we combine this 40 and the 6 together in one shot. And then when we move over to the 1, that's really a 10, so we adjust by putting the 0 for 10 here. And then we really just say 1 times 3 is 3 because we already got the 10 for the 30, and 1 times 2 is 2, and there in my next row is my 230. Okay. So this picture also shows the standard algorithm in rows, since I wrote 23 at the bottom and 12 on the side. Could be columns depending on how you wrote the numbers. And then we condense to get the answer. So we have the expanded algorithm here, the standard algorithm here, and then how the picture relates to them. And we're going to do an activity today, which is to take multiplication problems like what is 23 times 12, and then you're going to draw a picture or take a screenshot of the Math Learning Center picture, and then you're going to show how the expanded algorithm relates and the standard. But before we do the activity together, I just want to make sure you all got the same kind of idea about how we're going to illustrate these 2-digit multiplications. So we're going to do another example. So I would like you to try and draw a picture of, or go to the Math Learning Center app to demonstrate 34 times 23. So the goals here are to, 1, draw this area with base 10 blocks. And I'll draw mine by hand as well as use the Math Learning Center app. 2, show the expanded algorithm in comparison. And 3, show the standard algorithm. And there is a 4th step, which you could try or just wait for me to do it with you. What we want to do is we want to connect the drawing directly to the standard algorithm. So what I want to do for the 4th part here is kind of definitely show how the drawing relates to the standard algorithm. So the first stage of this is to make the drawing. So like earlier we had, I gave you the drawing of 23 times 12. I want you to make a similar drawing for 34 by 23. And you can use the Math Learning Center blocks, or you can try and draw it on a piece of paper. If you were drawing it on a piece of paper, which I'm going to attempt to do, first thing I usually do is I draw myself like a set of X and Y axes. And then on these axes, I mark my numbers. So I would mark what does 34 look like on this axis, and I would mark what does 23 look like on this axis. And when I do that, I want to make sure I show clearly the 2 10s and the 3 1s. And over here, I want to clearly show the 3 10s and the 4 1s. Just like on this picture here, I can clearly see for 23, there's 1, 2 10s across, and then 1, 2, 3. For 12, I can clearly see the 10 vertically and then the 2 1s vertically. Okay. So give it your best shot, and then we'll rejoin each other in a moment. All right, so if you're working on this still, that's okay. I'm gonna start talking as I work a little bit. So I've roughed out my drawing of what I think an area of 34 by 23 looks like with base 10 blocks in mind. So across the bottom here, again, I was making my base of 10, 20, 30, and then 1, 2, 3, 4. And then my height of 10, 20, 1, 2, 3. So this is my whole area. And I could do a few things here, like I could just right away make a note, hey, there's clearly 600 in this region, because that's 2 by 3. And this region on the side here, well, that's what, 4 by 2, and they're 10s, so there's 8 10s or 80 in this region. This is 3 by 3 with 10s, so it looks like there's 9 10s or 90 in this corner. And then this region over here are my 1s, and that's 4 by 3, and so there are 12 1s in there. So sometimes I like to draw that out right away. Now, those are 12 1s. So remember the trades we did earlier? I could here trade 10 1s for 1 10. And I'll do that in a minute in the Math Learning Center. Let's see, oh, the 90 and the 80, if I take one of the 10s from here, like this one right there, and I bring it over to the 90s here, then those groups together are gonna allow me to trade 10 10s for a 100 piece. All right, and I don't think I see any other trades. So let's actually do step 2. I'm going to show the expanded algorithm. So expanded algorithm for 34 times 23. 3 times 4 is 12. And then 3 times 30 is 90. And there's my 12 and my 90 in that top row. And then I move over here to the 2 for 20. 20 groups of 4 groups of 20 is going to give me 80. And then 20 groups of 30 is going to give me 600. And so the expanded algorithm is nice because it shows each of these regions here. So whenever I draw one of these base 10 block versions, I have a bunch of places that are 10 by 10, which make hundreds. And then I have these other places that are 1 by 10 or 10 by 1. So there's this kind of this natural split here that the 1s and 10s make for each individual number. And whenever I multiply 2 digits times 2 digits, I get this grid of 4 different regions. 10 by 10s, 1 by 10s, or 10 by 1s, and then 1 by 1s. And then I can put all of that together in the expanded algorithm. So I only have 2 1s total. I have 9 plus 1 is 10, plus 8 is 18, carry the 1. 1 plus 6 is 7, so it looks like the answer here should be 782. And just to highlight a couple of things, my trade of 10 1s for a 10 happened right here with that 1 from the 12 because it jumped to the next column. Anytime something jumps to the next column, a trade had to happen with the toys. And then I saw this other trade here, and that's this one right there. That 10 10s made 100. Ooh, I've got a share here. Somebody drew their picture in the Math Learning Center. I'm excited. Thank you for sharing. Ooh, that's wicked cool. Nice work. Yeah, so there's the 10, 20, 34 by 10, 23, and there's the whole answer in there. Nice use of the app. Thank you for sharing that. All right, let's get back to my sketching over here. All right, so I've got step 1 done. Got step 2. Standard algorithm is next. So my step 3, choose green for that. Standard. And what is the standard algorithm really? Well, the standard algorithm, kind of like the standard addition one, is the idea of this carrying digits somewhere else. Like 3 times 4 is 12, I carry the 10 from 12 up above. Let's make that red. And then I write the 1s from the 12 underneath. So the standard algorithm basically says if you get a digit in the next place value over, move it over to the next column. That's what the standard algorithm tells us to do. And tells us to do another thing. It tells us to keep a row in a row. So when I do 3 times 34, that's all going to be one row. So then I do 3 times 3 is 9 plus 1 is 10. And notice we jumped again. So this one right here represents that other trade. So that's one trade, we jumped, and here's another trade, we jumped. We were in the tens column, but somehow we jumped to the 100. Physically, trade happens. And then I fill in with a 0 because I'm jumping place value again. That's really a 2 for 20, but we just say to ourselves, 2 times 4 is 8. It's really 80, 20 times 4. 2 times 3 is 6. And then we collect stuff. So 2 and 0, 0 and 8, 1 and 6. So whether I use the expanded algorithm or the standard algorithm, some jumping of place value happens, which is a trade in the real toys. So I want to show that in the app in just a second. But now I'm on to step 4. I just want to write down the connection about how the drawing relates to the standard algorithm. And so I'm just going to put a little star right here and right here. And what do I mean by the star? Each trade in the image relates to a digit that was carried to the next column. And some kids are more concrete than others. A lot of kids have trouble with abstractions. Like I remember my kids, whenever we read a book and there was a metaphor in the book, they just did not get metaphors. Like, what do you mean he was running like a gazelle? He's not a gazelle, he's a human, right? It just went over my kids' heads. And then eventually they started to pick up, oh, I get it. He was just going really fast because the gazelles go really fast, right? So similarly with learning math, these abstractions some kids get and some kids don't. And the concrete picture can really help. So next I want to use the Math Learning Center to come up with this final answer here. And this is kind of cute, I think. All right, so if you didn't build this in the Math Learning Center, you can just watch me do it. If you did build this in the Math Learning Center, then you can do it with me. Not that one. Okay, here we go. So here's my version, big and chunky there. So in the Math Learning Center, you can highlight stuff by drawing a loop around it. So what I'm going to do is I'm going to think about that trade I did in the ones here, and I'm going to make a circle around 1, 2, 3, 4, 5, 6, 7, 8. I'm going to try to encase 10 of them. And it turns out it doesn't matter if you get it exactly right, but if you miss some, that's a problem. So how many did I do? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I messed up. So I'm just going to circle all of those guys there. Almost got them. And then I'm going to use this button on the bottom here, which says join those pieces together. And if you circled enough pieces, even if you circle a little extra, it'll say, oh, I can make a 10 out of that. And now I'm in the version of the app. Notice the bottom corner here. There are 2 different versions of this app. There's the app that colorizes. Oops, sorry about that, wrong button. Ah. Hitting the wrong button, stop it. Try this one more time. There we go. When we first open the app, it's usually in this mode here where we have all the same color, vertical and horizontal tens. At the bottom, there's a color code key that takes me to this different version of the app where tens are always red, sorry, hundreds are always red, tens are always green, and ones are always yellow. And when I circled those yellow ones and I had enough of them, it said, hey, you can do a trade there. Now I'm going to have to drag one of these green guys over here to do my trade. And then I am going to attempt to circle 10 of these green guys. Otherwise, I think the app might get confused. I think this is gonna work. And then I should highlight, it didn't like it. Okay, I'm gonna try it again. I can do this, I know I can. I can do hard things some days. I think if you just touch it with that line I'm drawing, it'll collect it. So close. Can I add on to it? Like a shift circle? Ooh, I can. So if I hit shift and select something, it adds that on. Okay, what do I got? All right, let me try this again. So, all right, click off of everything and then click the first one and then shift click the others. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it turns out I didn't even need to move that. But now I have enough to group and it says, okay, there's 100. All right, so then I kind of look at what I have, and I have 1, 2, 3, 4, 5, 6, 7 hundreds, 1, 2, 3, 4, 5, 6, 7, 8 tens, and 2 ones. And so now I can see my 782 answer by regrouping the original grid that I made. So I started with an array, and I ended up with this hodgepodge of pieces that shows the answer. That was fun, wasn't it? I thought it was fun. Okay, so let's take a look at activity 3, which is what we're warming up for. So activity 3, if you get to its homepage from the main page, it gives you a brief intro to it, and then you can hit start, or if you already looked at it, resume, and then it gives you more details. So we're using base 10 blocks to try and visualize multiplication, and 2 times 3 can be extended to look like something like 23 times 12, okay, which we already played with. And then we got more advanced and did the 34 times 23, where we had to do some trades. The 23 times 12, no trades needed. The other one we did, we had some trades. And so I could easily see there that the answer was 256, or 66, excuse me. Oh, wait, that's a mistake. 230. Oh, I wrote 20 here when that should say 40. Oh gosh, I have a whole bunch of mistakes here. What the heck was I thinking? Okay, I will fix that. Sorry about that. Down here, I have a few problems for you. I have 14 times 12, which is a pretty straightforward one like we did in the beginning. And then 15 times 13, that's going to involve a trade. 14 times 23, similar to the one we just did, but a little easier. And then 26 times 14. So your goal on here is pretty much that outline I did before. And this could be on paper that you take pictures of. You could use the Math Learning Center grids to do this if you want to, and take screenshots of that to put in Google Docs. Let's see, my recollection is with the share button, I can get that image there and then I could save it and then put it in a Google Doc. I don't think I can copy and paste into a Google Doc though. So that could be sketchy. I haven't tried it yet though. Back to the notes here. So the goal is to basically draw each of those multiplications that I give you. There's 4 of them. Then I'd like you to show the expanded and the standard algorithm. And then if some trades happen, then I just want you to make a note that the trades and the carries match up. Okay. Any questions on what I'm hoping for you to accomplish here? Okay. So I'm just going to show one more cute thing, and then I'm going to shut up and you can hang out and work and I can answer questions, or you could go on to the rest of your day, whatever that means. So we've gone over the modeling from section 3.2. We've talked a little about algorithms in terms of the expanded algorithm and the standard algorithm. There, it turns out around the world, there's a lot of other ways people do multiplication. So I just want to show you one of those ways now. Next class, I'm going to review the area model with base 10 blocks. I'm going to show you some other algorithms that are done around the world. And then we're going to look at number properties and some mental tricks for doing multiplication. So we're about halfway through section 3.3. All right, so into the notes, new page. Oh, magic pen, there you are. All right, so, oops. I'm gonna call this the cutest multiplication algorithm ever. It's really not the cutest, but it's pretty damn cute. Multiplication algorithm. There's actually a cuter one than this, I think, and there's a video on it in your homework, the cuter one. But this is pretty, wrong button. This is pretty darn cute. So let's take, for example, the problem we just did, which was, what was that? That was 34 times 23. So what you do is you turn this into a grid. And so the first number, 34, needs a column in the grid. And then the next number comes around clockwise. And so it's going to go down this way as 23. And so each digit needs a row. So I have a row and a column for each of these numbers here. And that was kind of messy, but I'm going to go with it. So there is my 34 times 23 coming around clockwise from the top. So like my base and my height. But this isn't quite that same area that I drew a minute ago, right? That's, oops, I guess it's not in this page. So then what I do is I draw diagonals through this, like this, from the upper right to the lower left. So I get my lefts and rights correct there, I think so. So each of these gets a diagonal. And then when I multiply, for example, let's see, 4 times 3 down here. 4 times 3 is 12. I write the 12 like that, one digit on each side of the slash. If the multiplication is a single digit, like 4 times 2 is 8, the ones always goes in the bottom or to the right. 3 times 2 is 6, and then 3 times 3 is 9 over in this grid. Do you see why I'm putting each number where it goes? 3 times 3 has no 10s and 9 ones. 3 times 2 has no 10s and 6 ones. 4 times 2 has no 10s and 8 ones. 4 times 3 has 1 10 and 2 ones. Right? So, or I can just say 4 times 3 is 12. And we write the 12 like that. Now, the cute thing here is that there are these diagonals formed, and we just follow the diagonals to get the answer. So 2 is the only thing in that diagonal right there. So I'm going to put a 2 here. 8, 1, and 9 are all together in there. 8 plus 1 plus 9 adds up to 18. So I'm going to write the 8 here and carry the 1 to the next diagonal. 1 plus 6 is 7, and there's the answer, 782. That's kind of cute, isn't it? I think it's cute. Okay, now I'm going to shut up, sort of.